Hello, the Math Dog here. So I'm going to derive the trig properties below using odd, even function properties and horizontal translations. So specifically, I'm going to show that the cosine of pi over 2 minus x is sine x. The sine of pi over 2 minus x is cosine x. The tangent of pi over 2 minus x is cotangent x. And this is a trig video. So let's get started. So I've done this in a previous video, but I'm going to do it again. How to do a quick sketch of sine and cosine using the unit circle if you forgot what they look like. And of course we have our famous saying in trigonometry, SOHCAHTOA, where sine is opposite hypotenuse, cosine's adjacent hypotenuse, tangent's opposite adjacent. Alright, so here I have a unit circle. Radius is 1. I've drawn a right triangle here in the first quadrant. This is angle theta. So the coordinates of this point here are x, y. Okay, and in this triangle, this would be, the length of this side here would be y. So notice from SOHCAHTOA that sine of theta is opposite or hypotenuse. So that's going to be y over 1. Therefore, y equals sine theta. Cosine of theta is adjacent over hypotenuse, so this is the opposite of theta. This is the hypotenuse, so what's left over always is the adjacent side. That's how I do that. So that's x over 1. So cross multiplying, you get x equals cosine theta. And tangent is TOA, which is opposite over adjacent, so that's y over x. But y is equal to sine theta, and x is equal to cosine theta, so tangent is sine theta over cosine theta. So now let's sketch sine and cosine using the unit circle. So again, on unit circle, radius 1, so at 0 degrees or 0 radians, the coordinates are 1, 0. At pi over 2 or 90 degrees, the coordinates are 0, 1. At 180 degrees or pi radians, it's negative 1, 0. And then at 0, negative 1, that's 270 degrees, or 3 pi over 2, the coordinates are 0, negative 1. So notice that from this here, x is also equal to cosine theta, and y is equal to sine theta. So that means that at 0 radians, 0 degrees, cosine is 1, sine is 0. Up here at pi over 2, 90 degrees, cosine is 0, sine is 1. At 180 degrees, or pi radians, cosine is negative 1, sine is 0. And at 3 pi over 2 radians, or 270 degrees, cosine is 0, sine is negative 1. So we can use this to quickly sketch out what sine and cosine sort of look like. So at 0 radians or 0 degrees, sine is 0. We'll start with sine. Let's do a different color there so we can see it. So sine is 0. At pi over 2 or 90 degrees, sine is 1. At pi or 180 degrees, sine is 0 again. At 3 pi over 2 or 270 degrees, sine is negative 1. And then back to 360 degrees or 2 pi, which puts us back at 0, it goes back to 0. Then we could go at, so that is a, I'm doing a positive rotation there. So counterclockwise is this way, and that's going to give you, counterclockwise is positive angles, and clockwise will be negative. So now I'm going to go clockwise. So the sine of negative pi over 2 or negative 90 degrees is negative 1. The sine of negative pi or 180 degrees is 0. The sine of negative 3 pi over 2 or negative 270 degrees is 1. And then the sine of negative 2 pi or negative 360 degrees is back to 0. So if you sketch these or put a line through these, we're going to not a line, we're going to put a curve. It's going to curve like this because if you put in some of the other trig ratios here, like 30 degrees, 60 degrees, 90 degrees, you're going to get this curvature like this. So sine is a periodic function because it just keeps repeating itself forever. So that's basically a quick sketch of what sine looks like. Okay, then cosine is the x-coordinates here. So cosine of 0 is 1. Cosine of pi over 2, or 90 degrees, is 0. The cosine of 180 degrees, or pi, is -1. The cosine of 270 degrees, or 3 pi over 2, is 0. And then back to 2 pi, or 360 degrees, it's going to be 1 again. Okay, so cosine is the red, and sine is going to be, what color did I use there? Basically, I use this. Sine is going to be that color. Okay, so then going backwards for cosine, cosine of negative pi over 2, or negative 90 degrees, is 0. Cosine of negative pi, or negative 180 degrees, is -1. Cosine of negative 270 degrees, or negative 3 pi over 2, is 0. And then the cosine of negative 2 pi, or negative 360 degrees, is 1. So you can see that the offset for these angles is going to be negative 90 degrees, or pi over 2. Okay, so I like to be able to make a quick sketch of sine and cosine, so I'm going to demonstrate that now. So I will just do this, and it's because I don't have all this stuff memorized. I have sine and cosine memorized, but not some of these offsets that I'm doing in these videos. I don't have that memorized. I just draw a quick sketch. That's the easiest way for me to do it. This doesn't take that long to do. So this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is negative pi over 2, negative pi, negative 3 pi over 2, and I guess I need to extend this out a little bit. So, excuse me, I will do that. This is 0, 1, -1. So sine I'll do in, I'll green this time. So this is sine. I like to sketch it in quarters. All right, so it's not a beautiful thing, but it's good enough. So because I can answer a lot of questions with this. Now cosine I'll do in red again. Starts at 1. So it is helpful to know that sine 0 is 0, and cosine, that should be 0. Cosine of 0 is 1. That's your starting point. So cosine goes like this. All right, again, notice the offset of pi over 2. All right. So now recall horizontal translations. Again, I've done this in a previous video, but I'm going to do it again here. So given f of x minus h is a shift h units to the right. Remember, the minus actually is the opposite of what you think. You might think this is going to be a shift left, but actually that's a shift right horizontally. So here's the function f of x. I shift it h units right. We get f of x minus h. Likewise, given f of x is f of x plus h, that's a shift actually of h units left. Notice that f of x minus negative h, in fact, is f of x plus h. So we're shifting it left. So we start here, we shift it left h units. Okay. Then recall reflections over the x-axis. Given f of x, negative f of x is a reflection over the x-axis. So here is f of x, here's like a mirror, and negative f of x is a mirror image of f of x over the x-axis. Okay, quick review of odd and even functions. If f of x equals f of negative x, then we say the function is odd. I'm sorry, is even. It's even. Okay, notice that if I have this parabola here, this turns out to be an even function. Here's the point x f of x, and here's the point x negative f of x. This should be negative x here, not x. That's negative x f of negative x. Notice that negative x and x both generate the same height on the function, therefore they have the same value. So if f of x equals f of negative x, the function is said to be even again. If the left side of the function is a mirror image of the right side, we can just look at the function and tell it's even. So notice that the right side is here, left side is here, they are mirror images of each other. So now let's demonstrate algebraically why f of x equals x squared is an even function. So we have f of x equals x squared, therefore f of negative x is going to be, I replace everywhere in f of x, I replace x with the negative of x, which is going to be x squared, because a negative times a negative is a positive. So notice that these two are equal, therefore f of x, this means therefore, is equal to f of negative x, and therefore f of x equals x squared is even. Alright, so now let's look at odd functions. So we say if f of x equals the negative of f of negative x, then a function is said to be odd. So here is an odd function, snakes like this. This could be like f of x equals x cubed. So if I then take f of negative x, which is a reflection of f of x over the y-axis, I get this dotted yellow graph here. Notice that f of x and f negative x do not match each other. So this is not an even function, which I probably should have said that over here. So if a function is even, in fact, the graph of f of x and f of negative x, in fact, will be identical to each other. So yes, it is the left side is a reflection of the right side, but you're going to get the exact same graph. So in our odd function here, we do not. However, then if I take negative f of negative x, that is a reflection over the x-axis, and we get what we started with. So that shows that f of x equals negative f of x. So f of x in this case equals negative f of negative x, and we say the function is to be odd. The function is odd. So if you can rotate a function 180 degrees about the origin and it matches itself, then the function is odd. So you can spot an odd function by just looking at the graph, as you can do with an even function. So let's take a look algebraically why this meets the criteria, why f of x equals x cubed meets the criteria for an odd function. So notice that f of negative x is the negative of x cubed, because everywhere there's an x, I replace with negative x. Well, that's the negative of x cubed. So this function is not even because it doesn't match. But then if I take the negative of f of negative x, that's going to be the negative of negative x cubed. So I'm taking a negative of this. Well, that's a double negative, makes positive, so that is x cubed, so we get what we started with. So therefore, f of x in this case is equal to the negative of f of negative x. It should be pointed out perhaps that most functions are neither odd nor even. Okay? So now let's take I've done this in previous videos, but I'm going to mention it again because I think it's important. So let's look at the graphs of sine, cosine, and tangent, since that's what we're dealing with in this video. So notice if I take the sine function, rotate it 180 degrees, any part of it, it matches itself. So like a propeller on an airplane. So sine is going to be odd. Thus sine of x is the negative of sine of negative x. Okay, so then this is cosine of x. Notice that if I reflect it over the y-axis, it'll exactly match itself, so cosine is even. Thus cosine x is equal to the cosine of negative x. Okay, So then tangent, which looks like this, I'm not going to explain why it does this in this video, but tangent, if you rotate 180 degrees, matches itself, so it is odd. Thus tangent x is equal to tan of negative x. Tangent of negative x. Alright? So here I've got 4 graphs. So sine x is in red, cosine x is in blue, and then negative sine x is going to be a reflection of sine x over the x-axis. So here's sine x again. Notice that negative sine x is a reflection of sine x over the x-axis. And likewise, cosine x, which is here, negative cosine x is a reflection of cosine x over the x-axis. Alright, so now let's take a look at show why cosine of pi over 2 minus theta is equal to sine theta. So what I'm going to first do is I'm going to start out with, and I did this in a previous video, what the cosine of theta minus pi over 2 is. So cosine theta is in blue here. Okay, so this is a shift pi over 2 to the right. So notice this is sine theta. So if I shift cosine pi over 2 to the right, I get sine theta. Okay? Therefore, okay, remember that cosine is even, so therefore cosine of theta equals cosine of negative theta. So therefore, I can write that cosine of the negative of theta minus pi over 2, well, this has to equal this. So this has to equal sine theta also. But what does this equal? So this is the cosine of the negative of negative pi over 2 is pi over 2 minus theta. So the cosine of pi over 2 minus theta must equal sine theta, which is what we just proved. Okay. Now show why sine theta of pi over 2 minus theta, show why sine of pi over 2 minus theta is equal to cosine theta. Okay, well, here's sine theta. Okay, I'm shifting it, so we're going to start with this, sine of theta minus pi over 2. Okay, well, here's sine theta. If I shift it right to here, notice that is equivalent to, here's cosine theta, so this is negative cosine theta. Because the yellow graph is the blue graph shifted pi over 2 to the right. So here's sine, you're shifting it to right here. But then we know that sine is odd, therefore negative sine of negative theta minus pi over 2 is equal to negative cosine theta. Okay, so this is then, we can then say that sine, I divide everything by -1, so sine of negative of theta minus pi over 2 has to equal, so I'm dividing everything here by -1. You could put a -1 there. Okay, so this has to equal cosine theta. But now this is the sine of negative pi over 2 is pi over 2 minus theta, using your distributive property, equals cosine theta. And that's what we're trying to prove here. Okay, that's what we just did demonstrate. Okay, then last, why is tan of pi over 2 minus theta equal to cotangent theta? Well, we can write, we know tangent sine over cosine. We showed that at the beginning of the video. So the tangent of theta minus pi over 2 equals the sine of theta minus pi over 2 all over cosine of theta minus pi over 2. Okay, but sine, let's just do it off this graph. Sine of theta is right here. Shifting pi over 2 to the right, like what we're doing here, that gives us, again, that's equal to negative cosine theta. So that's negative cosine of theta. And then cosine, shifting cosine pi over 2 to the right, here's cosine. shifting it pi over 2 to the right gives me sine theta. Okay. So now we have tan theta minus pi over 2 is equal to negative cosine theta over sine theta. Okay, but tangent is odd, therefore this has to equal the negative of tangent of the negative of theta minus pi over 2. And by the way, since sine over cosine is tangent, the reciprocal of tangent is cotangent, so this has to be negative cotangent theta. Alright, so now I can divide, that's negative 1, I can treat that as negative 1, divide by negative 1 both sides, I get tangent of negative of theta minus pi over 2 equals positive cotangent theta. So now, using my distributive property inside the parentheses, that's negative pi over 2, so that's pi over 2 minus theta equals cotangent theta, and that's the result we were seeking to show here. There it is. And this concludes this video presentation. If you found this video informative and helpful and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.